Hi, I'm Andrew.
Hi, I'm Lauren.
Hi, I'm RJ. Hi, I'm Emil.
Hi, I'm Dombey.
Okay, that's fine.
So we approached this problem by dividing and conquering the three different parts. Three of us worked on problems 1 and 2 together because those were pretty well connected, whereas the other two worked on problem 3 more independently, and then we would check back in every few hours to make sure everybody had the resources they needed and knew what they were doing.
For problem 1, we derived a differential equation based off of Newton's law of cooling, and we applied it to this problem. We solved it using Euler's method by defining a starting temperature, and for the starting point, we changed it based off of what time of day it was, and we generated our own sine curve for the indoor temperature.
For part 3 of the problem, we first defined all the variables that we thought would be important for the final model, which would determine the vulnerability score. And after defining the models, we formulated the model and used it to determine the scores for the different neighborhoods in Tennessee.
So for our Python script to do Euler's method for us, we used Plotly, Matplotlib, Pandas, and NumPy. And basically what we did is we had a list of different temperatures at different points of the day, and we used to use only one of them for the starting temperature. And what would happen is the curve resulting from Euler's method would just converge to that temperature, but as we varied it based on the time of the day, we got a sine curve out of it. So that was one of the changes that we made to improve our model.
So as you recall, our equation for part 2 deals with the amount of heat that enters a home based on the temperature we got from part 1. So as you can see here, this is really an iterative differential equation based on our result from part 1. We already know the values for this time in minus time out, temperature inside minus temperature outside. And so we can just plug those in for each of the houses we found in part 1. And then the constants will remain the same, and we just plug in the initial heat that we found to get a value for part 2. Only thing is, make sure you don't forget the negative that ended up making us waste 30 minutes.
While we were doing this challenge, we made sure that we had fun along the way and got closer with each other. Some of the stupid but fun things that we did were:
I got a haircut.
watched a little bit of good TV,
Crashed a 50th birthday party for food, with his permission, of course.
and me, Anil, and Andrew had a sleepover.
Go.